Good morning, my students. So, this is me again, continuing with the complex number. We are still in math for grade 2. So, this is advanced mathematics. We reached to Euler form. So, kindly try to write everything in your copybook. So, in a case that you have any question, you are free to come and ask me in my office. We'll start the easiest part of this section. I just summarized that Euler form, it's e to the power of I theta. It's equal to cosine theta plus I sine theta. What does this mean? If we write it in the polar form, as I have explained to you last lecture, we know that z equal to I, so let me write it here, in simplest way, it's r cosine theta plus I r sine theta. This is what we took last lecture. So now I want to convert this form into this form. What do we have an extra thing? We have the r, which is the absolute value or the value of the complex number. I will just take it out. We will have r cosine theta plus I sine theta. This r is outside of the bracket. You see this cosine theta plus I sine theta? It's exactly like this. Cosine theta plus I sine theta. So what's the exponential function of I theta? It's here. I can say that it is equal to, I will put the exponential function of I theta, but I have extra r in here, I will put it at the beginning. So this is z in Euler form. Why do we need to convert to Euler form? It's very important to find some complicated result. We cannot find it in normal mathematics. We'll take an exercise later. But before that, we have to understand what is the inverse of z. You see, inverse of z, as we took last lecture, is 1 over z, right? Inverse of 7 is equal to 1 over 7. Inverse of z is 1 over z. So if you know that z is r e to the power of I theta. So what's 1 over z? It is 1 over r e to the power of I theta. But this time, this will be in minus. Why? Because it was down. When I take it up to the denominator, I have to make the power to the minus, as you know in simple mathematics. Now let me go to the multiplicative. So suppose I have z1 and z2. I want to multiply z1 times z2. What the result gonna be? So what is z1? As you know that z1 is from here. Let me take the simplest form. Is r e to the power of I theta times z2. What is z2? It's times r2 times e to the power of I theta. So what the result will be? As you see here, r1 times r2 is r1, r2. This is the exponential function, and when we multiply the power, we have to add them together. So, as in simple mathematics, the result will be r1, r2 times I, and we have here theta 1 for z1, theta 2 for z2. So I take I outside because I, it's I, either in z1 or z2. But theta, the angle is different, is going to be theta 1 plus theta 2. So, if we take the division how it's going to be. Z1 over Z2, you know that Z1 is R1 divided by R2, okay? Z1 is exponential of theta 1 times the complex number I. So it's exponential of I theta 1 over exponential of I theta 2. The result is R1 over R2 is the real value which we don't know, it's assumption. So I keep R1 and I keep R2. But this exponential of I to the power of theta 2, I can take it up to the denominator, it will be E to the power of, I take I outside, then I have theta 1 minus theta 2. So, this is the main aim of today's lecture. We will take some exercises to simplify the assumption which we proposed before. So, in the exam you will find a simple question like this. I changed the number. There are no ideas in complex. The ideas are same. So, let me start right now. Suppose the question is, solve the following equations in polar form. So once it says that it's in polar form, that means you have to convert your calculator from degree to radius. If you don't do this, you will get a wrong answers. So focus with me. Here it says that the equation is 2 plus 2 root of 3 of I. So what's the first thing I should find? I should find R. Let me use different color. So here R is going to be root of this number squared plus this number squared. What is our aim? We have to find Euler form to solve this equation. So let me convert it to Euler form. First of all, I should find R. Then I find theta, the angle. If I find R, I find theta, I can convert it to polar form using Z. So first of all, I will find this number squared plus this number squared. So this is 2 squared plus 2 root of 3 all squared. The result is 2 squared is 4. Root of 3 squared is 3 times 4, the result is 12. So I have here 14 plus 12, the result is 16, root of 16 is 4. Suppose I want to find theta now. Theta equals to, as you remember, is tan to the power of minus 1, okay? You take the complex value, which is 2 root of 3 over 2. So tan inverse of root of 3. This thing, you can use your calculator, or you can just say it's tan to the tan inverse of root 3, which as far as I think it's 30 degrees. So let me confirm. The result is, you can use your own calculator as an exercise. It's 60 degrees, which is pi over, it's 60 degrees. You know that pi is 180. So 60 degrees mean pi over 3. So this is the result. So if I want to convert it to Z, so now Z equals 2 R cosine theta plus I sine theta. So how much R do we have in here? R is 4. Cosine 60 plus I sine 60. Okay? if we convert this thing to Euler form, it will be r, which is how much? Plus 4. So 4 exponential of I, and how much is theta in here? Is pi over 3. Okay, so this is gonna be the result. Let me continue. This time I will solve it faster to get the Euler solution for this result. So let me solve it faster. So what is r in here? Equal to root of 25 plus 25, which is 5 squared plus 5 squared, which is root of 50, which is 5 root of 2. Now I want to find the angle. We have said that angle is theta equal to tan to the power of minus 1. The value divided, the complex value divided by the real value, which is 5 over minus 5. Result is tan of minus 1. Using your calculator, put it on radius, you will find the angle, which is, I'll use my calculator. It's minus 45 degree. That means minus pi over 4. The result is minus 45 degree, which is minus pi over 4. Okay. Try to buy same calculator as we have at the university here. That means you have to know how to convert from degree to polar in order to find the exact degree. Now, let me find the angle. So, my aim is to find r exponential of I theta. So, what is r in here? R is 5 root of 2. What is the angle? You know, it's exponential of theta. How much is it? Minus pi over 4 times I. So this is the final result in polar system. I'm solving the complex equation, the complex combination equations using Euler form. Let me jump to the last exercise. I will find r equal to root of, what is the first value I have? 1 squared plus, what do we have in here with the imaginary form? I have I, so it's 1 squared also. 1 squared. The result is root of 1 squared plus 1 squared is root of 2. I need to find the angle. You know that angle is tan inverse of this component divided by this component. So what do I have? 1 divided by 1. So tan inverse of 1. Tan inverse of 1 is 45 degree. So it's already 4. So it's 45 degree. 45 degree is 180 divided by 4. So it's pi over 4. So this is pi over 4. I'm converting everything to polar system. So now I will find the form of Euler, which is r exponential of I theta. You know r is root of 2 exponential of how I state I times pi over 4. So this is the final result. As a homework, try to solve this one. This is the end of today's class. As you notice, it's simple, fast. and you can write everything from the board by stopping the video. I wish you all the best. In a case that you have any question, please don't hesitate to contact me in my office hour. See you next lecture. Thank you very much.